The snow was coming down so hard that Sarah Hollenbeck couldn't see her woodpile from the cabin window. Not that it mattered. The firewood she'd spent 3 months cutting, splitting, and stacking was buried under 4 feet of wet, heavy snow, frozen into a solid mass that would take days to chip apart with an axe. Her wood stove was down to its last 6 pieces of dry kindling. Outside temperature, 12 degrees Fahrenheit. Inside, with the fire dying, 41 and dropping. Her nearest neighbor lived 17 miles down a dirt road that wouldn't see a plow for another week minimum. She had 2 choices: burn furniture or figure out why her hands weren't shaking anymore. That second option worried her more than the cold. But 8 months earlier, none of this should have happened. Because 8 months earlier, Sarah had made a decision that everyone told her was insane. She was going to dig out the hillside beneath her cabin and build a covered storage structure underground. Not a root cellar, not a basement. A full-sized Quonset hut buried into the mountainside, accessed by a sloping ramp, designed to keep an entire winter's worth of firewood bone-dry and accessible even in the worst blizzards Wyoming could throw at her. Her cabin sat on a south-facing slope in the Bighorn Mountains, elevation 7,200 feet, where winter meant 6 months of snowfall averaging 240 inches. She'd spent her first winter there learning what wet firewood meant. Smoke, creosote buildup, half the heat output, and a chimney fire that nearly burned her cabin down in February. The folks at the hardware store in Sheridan thought she'd lost her mind. "You're gonna dig into a hillside, under your cabin?" Tom Reichert set down the surveying stakes she was buying, his expression somewhere between concern and disbelief. He'd lived in northern Wyoming for 63 years, built his own place back in '78, and considered himself an authority on mountain living. "Sarah, that's your foundation we're talking about. You undercut that slope, the whole thing slides, and your cabin goes with it." She'd heard it before, would hear it again. But Tom's objection was at least grounded in legitimate engineering concerns, unlike some of the others. "Not planning to undercut it," she said, spreading her hand-drawn plans across the counter. "The cabin's foundation is 8 feet of exposed hillside above where I'm digging. I'm going in 22 feet back, 14 feet wide, with the Quonset hut providing the structural support. The arch distributes the load. It's basically a tunnel with a steel roof." Tom studied the drawings. "Where'd you learn to draft like this?" "Structural engineering degree. Worked in Denver for 6 years before I figured out I hated cities more than I loved steady paychecks." She pointed to the elevation calculations. "I'm cutting into stable substrate, sedimentary rock with a clay cap. Already did test cores. It's solid. And you're doing this alone?" "That's the idea. In 1 summer. That's the timeline." Tom folded his arms, the kind of gesture that came before a lecture. "Sarah, I'm not trying to be difficult, but you're talking about excavating, 300 cubic yards of material, building forms, pouring footings, assembling and setting a Quonset frame, backfilling, grading for drainage. That's a 6-person crew for 2 months minimum. You weigh maybe 130 soaking wet." 138, she corrected. "And I've got a hydraulic excavator rented for 3 weeks starting Monday. Everything else is hand tools, come-alongs, and mechanical advantage." The skepticism in Tom's face wasn't mean-spirited. He'd seen plenty of newcomers show up in Wyoming with big plans and inadequate understanding of what mountain winters actually demanded. Most left after their first year. The ones who stayed learned humility fast, usually through near disasters that could have been avoided with local knowledge. He was trying to save her from becoming a cautionary tale. But Sarah had done her homework. She'd spent 16 months in that cabin, documenting every storm, measuring snowfall patterns, tracking how wind deposited snow on different parts of her property. She'd mapped the sun's path across the slope to determine optimal placement for the entrance ramp. She'd consulted with a geotechnical engineer in Billings who'd reviewed her soil tests and calculations. The plan wasn't reckless. It was methodical. The problem was, methodical didn't always look smart to people who valued conventional wisdom over engineering data. "Look," Tom said finally, "you seem like you've thought this through. But if that hillside starts moving, or you hit water, or the tunnel collapses, then I'll have learned something expensive," Sarah finished. "Appreciate the concern, really, but I'm doing this." She paid for her steaks and left, knowing that conversation would be repeated in various forms over the next 6 months. She was right. By the time she'd marked out the excavation site and started moving equipment up the mountain road, 3 more people had offered their versions of, "This won't work." Frank Delaney, who delivered propane to the area, said the vibration from the excavator would crack her cabin's foundation. Carol Pritchard, who ran the post office, warned about radon gas accumulating in underground spaces. Miguel Santos, a contractor from Buffalo who sometimes worked in the area, told her that Quonset huts were meant for above-ground use, not buried installations where ground pressure would crush the corrugated steel. Each objection sounded reasonable. Each came from someone with more experience than Sarah had in mountain construction. And each was missing a piece of the puzzle she'd already solved. The excavator arrived on a Tuesday in late May. The driver, Eddie Gorman, took one look at the slope and shook his head. "Angle's too steep. Machine'll tip forward." Sarah had already cut a bench into the slope using a pickaxe and shovel. 4 weeks of work, creating a level platform where the excavator could work safely. Eddie examined it, checked the compaction. "Huh. You cut this yourself?" "Every inch." The first bucket of earth came out clean, reddish clay mixed with small stones, exactly what her core samples had promised. By the end of day 1, she had a gash in the hillside 8 feet deep and 12 feet wide. The cabin above showed no movement, no cracks. By day 3, they were 16 feet in, and the skeptics started showing up. Tom arrived first, then Frank. Miguel came by on a Saturday, bringing his son-in-law Carl, who worked in mining. They waited for the disaster they'd predicted. It didn't come. By the end of week 2, Eddie had carved out a space 22 feet deep, 14 feet wide, and tall enough for a 10-foot Quonset hut with clearance for backfill. The walls were vertical, the floor level, the back wall exposed bedrock that would never move. "I'll be damned," Eddie said on his last day. "You calculated the overburden load?" 12 feet of soil above the planned Quonset peak. At roughly 90 pounds per cubic foot, that's 1,080 pounds per square foot. "The Quonset arch is rated for 2,400. Eddie nodded. "You really are an engineer." The skeptics hadn't left. If anything, the successful excavation had deepened their concern. Because now Sarah was about to attempt the part that actually could go wrong: assembling and setting a Quonset hut inside a hole in the ground. Quonset huts, those half-cylinder structures of corrugated steel, had been designed in 1941 for military use, simple buildings that could be shipped flat and assembled quickly without skilled labor. They relied on the arch shape for strength, the curved panels bolting together to create a self-supporting structure that handled snow loads beautifully. Thousands of them still dotted the American landscape, used as workshops, storage sheds, airplane hangars, even homes. But they were always above ground, where the arch could push outward against foundation walls. Sarah's plan called for burying one in earth, where lateral pressure would push inward from all sides. That's what worried Miguel. "Steel's strong in tension," he explained to Sarah one evening, standing at the excavation's edge. "But you bury this thing, you're putting it in compression. Soil pressure pushing in from every direction. That corrugated steel's only 16 gauge, it'll buckle." "Not if it's properly braced during backfill," Sarah said. "I'm using internal cross-bracing every 4 feet, and I'm backfilling in lifts, alternating sides to keep lateral pressure balanced." In theory. In engineering. Miguel wasn't hostile. He was genuinely worried. His son-in-law, Carl Zimmerman, worked in underground mining and had seen plenty of tunnel collapses. "Ma'am," Carl said, "I respect what you've done so far, but underground work is different. You get unexpected water, or the backfill settles unevenly, or I've miscalculated, and we find out the hard way," Sarah interrupted. "I know, but here's what I also know. I can't do another winter with wet firewood. Last February, I had a chimney fire that could have killed me. The creosote buildup from burning damp wood nearly burned my cabin down. I'm not being reckless. I'm solving a problem that will kill me if I don't fix it." That stopped the conversation. Because Carl and Miguel both knew she was right. Chimney fires killed people every winter in Wyoming. Wet firewood was a legitimate danger, not just an inconvenience. The Quonset kit arrived in mid-June. Each panel weighed between 40 and 65 pounds. Sarah hand-carried them down the ramp using come-alongs attached to a wooden support frame to lift panels into position. By sunset on day 1, she had 3 panels connected, forming the beginning of the arch. Tom stopped by that evening. "You need help?" "Thanks, but I've got it." It took her 11 days to assemble the complete arch. Her hands developed new calluses. She lost 7 pounds. At night, she'd feel the day's work in every muscle. The arch, when complete, was beautiful. The corrugated steel catching afternoon light, the curve mathematically perfect. She started backfilling on a Monday in early July. 6 inches of gravel on each side, tamped with a hand compactor. Check the Quonset for movement. 6 more inches, alternating sides. Repeat. She'd installed internal bracing. Steel pipes every 4 feet, designed to resist inward pressure. Miguel and Carl came by on day 3. "No buckling yet," Miguel admitted. "It's still early," Carl said. "The real test is when you're past the spring line." She hit the spring line on day 6. The Quonset showed 1/8 inch of inward movement on the north side. She adjusted her backfilling. The deflection stopped. By day 12, she'd backfilled to the crown. The Quonset was completely buried. Maximum deflection, less than 1/2 inch. Miguel walked the site on the final day. He didn't say anything for a long time. "I was wrong," he said finally. "I thought it would buckle." "So did I, a little," Sarah admitted. The entrance structure went up next, an 8-foot wide ramp with a timber frame and metal roof, angled to shed snow. 4 days for the frame, 3 for the roof. By the end of July, it was complete and weatherproof. She spent August cutting firewood. 8 cords total, 1,024 cubic feet of stacked wood, roughly 23 tons. Beetle-killed lodgepole pine from Forest Service land, dry and ready to burn. 4 hours morning, 3 hours afternoon, 7 days a week. Felling, limbing, bucking, splitting, hauling, stacking. By the 3rd week of August, she had 4 cords stacked on pallets inside the Quonset. The temperature stayed constant at 58 degrees, cool enough to prevent insects, dry enough to prevent moisture. The firewood's moisture content dropped from 18% to 14%, a 9% increase in heat output, translating to 1/2 cord less wood needed for winter. September 19th, she finished her 8th cord. Standing in the Quonset hut, looking at the walls of stacked wood, she felt something close to satisfaction. This was security. The first snow hit on October 2nd. Not a big storm, just 3 inches of light powder that melted within 2 days. But it confirmed what Sarah's entrance design needed to handle. The snow drifted against the cabin's south wall, where the entrance ramp descended, creating a natural accumulation point. She'd anticipated this, building a small roof extension over the ramp's top that diverted the drift pattern away from the door. It worked. The entrance stayed clear. The second storm arrived October 18th, 8 inches of heavy, wet snow. Sarah watched it pile up on the roof extension, saw the drift pattern form exactly where her calculations had predicted it would. The entrance remained accessible. She walked down the ramp, opened the door, and checked the interior. Dry. No moisture, no dripping. The Quonset's buried position kept it insulated from temperature swings, maintaining that steady 58 degrees while the outside temperature dropped to 14. She grabbed an armload of firewood from the stack nearest the door. The wood was lighter than it should have been, moisture content down to 12% now, having spent 2 months in the controlled environment. She carried it up the ramp, loaded her wood stove, and lit the kindling. The fire caught immediately, the dry wood igniting with almost no smoke, burning hot and clean. Her cabin's interior temperature rose from 56 to 68 degrees in 40 minutes. With wet wood the previous winter, the same temperature increase had taken 90 minutes and produced enough smoke to set off her detector twice. November brought the real storms. Wyoming winter didn't mess around. When the snow started, it came with conviction. On November 9th, a system moved in from the northwest that dumped 17 inches in 22 hours, with winds gusting to 45 miles per hour. Sarah watched the drifts form from her cabin window, saw snow pile up against every windward surface on her property. The entrance ramp accumulated 2 feet of drift at its top edge. She grabbed a shovel and cleared it in 15 minutes. The ramp itself, angled and covered, had shed most of the snow naturally. The door opened with no resistance. Inside, the Quonset remained dry, the temperature unchanged, the firewood exactly as she'd left it. That storm was followed by 3 more in November, each dumping 10 to 20 inches. By December 1st, Sarah's property had accumulated 63 inches of snowpack. The drifts against her cabin's north wall were 8 feet deep. Her solar panels, mounted on a pole system 20 feet from the cabin, were buried and useless. She was running her backup generator 6 hours a day, burning through propane to keep her batteries charged, but her firewood stayed dry. She developed a routine: morning coffee, check the weather, shovel the ramp entrance if needed, grab an armload of wood, load the stove, work on whatever project occupied her day. The consistency was oddly comforting. No more desperate searches for dry kindling, no more trying to split frozen rounds with an axe, no more chimney fires from creosote buildup. Tom stopped by in mid-December, snowmobiling up from the main road because the access road was impassable. He'd brought mail and wanted to check that she was still alive. "How's the firewood storage working?" he asked, warming his hands near her stove. "Come see for yourself." She led him down the ramp. Tom stood in the Quonset hut, looking at the remaining 6 cords of neatly stacked wood, and shook his head. "I thought this was a mistake," he said. "Thought you'd have water problems, or the structure would fail, or, hell, I don't know. I just didn't think it would work." "Why not?" "Because it wasn't how we do things around here. We build woodsheds, above ground, with gaps for airflow. Your way was different, and different usually means wrong in this country." "Sometimes different means engineered." Tom laughed. "Yeah, I'm starting to see that." He helped her carry up an armload of wood, then rode off on his snowmobile, disappearing into the white landscape. Sarah watched him go, then returned to her cabin and added 2 splits to the fire. The wood caught immediately, burning with that clean, hot flame that only comes from properly dried fuel. January was worse, not in terms of snow, though it kept falling another 74 inches through the month, but in terms of cold. The temperature dropped below 0 on January 6th and stayed there for 11 consecutive days. The low on January 9th was minus 23 degrees Fahrenheit. Sarah's water system, buried 3 feet underground, froze despite heat tape. Her truck wouldn't start. Her propane regulator froze twice, requiring her to thaw it with a hairdryer to get her generator running. But her firewood stayed dry. She burned through nearly a cord that month, loading her stove 4 times a day, keeping the cabin temperature above 60 degrees through sheer stubbornness and good fuel. The Quonset hut never dropped below 48 degrees, even when the outside temperature was minus 20. The Earth's thermal mass acted as insulation, moderating temperature swings that would have frozen any above-ground storage structure. By February, she'd settled into a kind of winter equilibrium. The snow kept falling. The cold kept coming. But she had a system that worked, and that system meant survival wasn't a daily question anymore. It was simply what happened when you prepared correctly. Then March arrived with the storm that tested everything. The forecast called for a major system, but forecasts in Wyoming were more like suggestions than predictions. Sarah knew something big was coming when her barometer dropped from 30.12 inches to 29.54 in 6 hours on March 4th. She'd learned to read pressure drops like that. Rapid changes meant bad weather, and this was dropping faster than anything she'd seen all winter. The snow started on March 5th at 2:47 in the afternoon. Light at first, then steadily heavier, until visibility dropped to less than 50 feet by sunset. She went to bed that night with the wind howling and the cabin groaning under stress. She woke to silence. That was wrong. Storms weren't silent. She looked out the window and saw white. Not snow falling, but white, solid. Her window was completely buried in drift. Sarah dressed quickly and tried the front door. It opened 3 inches before hitting packed snow. She pushed harder. The door moved another 2 inches. She could see daylight through the gap, but that was it. She was buried. No panic. Panic was useless. She assessed the situation. She had food for 2 weeks. Water from melting snow. Firewood for another 3 months if she rationed. She had a satellite phone for emergencies. She could dig out. It would just take time and a lot of shoveling. But first, she needed to make sure the firewood storage was still accessible, because if that was buried too, she had a much bigger problem. She grabbed a flashlight and worked her way through the cabin to the back door, a secondary exit she'd installed the previous summer, specifically for situations like this. It opened onto the hillside above the cabin, where drifting patterns were different. She pushed it open, expecting resistance. It opened freely. The hillside had wind scoured, the snow blown into the valley below. She could see her entire property from here, or what remained visible of it. The cabin was buried on 3 sides, only the roof and the hillside-facing wall exposed. The entrance ramp to the Quonset hut was somewhere under 8 feet of drift. Her solar panels were gone, completely submerged. Her truck existed only as a white mound that could have been a boulder for all the shape it showed. She was stuck until the snow settled enough to dig out. Could be 3 days, could be a week, could be longer if another storm came through. Sarah climbed down the hillside, circling around to where the entrance ramp should be. She started digging using a snow shovel to move the light, powdery drift. It was like shoveling air. Each scoop removed almost no mass, the snow so fine and dry that it collapsed back into the hole she'd created. She dug for 3 hours, making about 2 feet of progress before exhausting herself. This wasn't going to work. Not quickly enough. She returned to the cabin and considered her options. The firewood inside would last about 6 more days at her current burn rate. She could ration it, stretch it to 10 days maybe. But then what? Burn furniture? Wait for rescue that might not come for weeks? There was another option. A backup plan she'd built into the system but hoped never to use. When she'd constructed the Quonset hut, she'd installed a secondary access point, a vertical shaft rising from the back of the storage area up through the hillside, fitted with a steel hatch at ground level. It was designed as an emergency exit, a way out if the main entrance failed or if she needed to evacuate quickly. The hatch was 3 feet square, covered with a simple weather seal, and marked with a bright orange pole so she could find it in snow. She'd never used it, never even opened it after installation. But if the drift had buried the main entrance under 8 feet of snow, maybe the hilltop access was clear. Sarah grabbed her snowshoes and climbed back up the hillside, working her way to the location where the hatch should be. The orange pole was visible, sticking up through the snow like a beacon. She dug down to the hatch, cleared the seal, and lifted the cover. Darkness below. She dropped the flashlight down and heard it clatter on concrete, 12 feet down, the fall cushioned by a wooden ladder she'd built into the shaft. She descended carefully, her boots finding each rung, until she reached the floor of the Quonset hut. The firewood was exactly as she'd left it, dry, stacked, ready to burn. She loaded her backpack with splits, climbed back up the ladder, and emerged into daylight. The whole trip took 20 minutes. She could access her firewood through the emergency hatch as long as the orange pole stayed visible, which meant as long as snow didn't exceed 15 feet deep, she was fine. The storm lasted 3 more days. Sarah monitored the snow depth from her cabin, watching it accumulate until the total measured just over 11 feet in the valley where her cabin sat. The drifts against the north wall peaked at 14 feet before stabilizing, but the hilltop remained scoured, the emergency hatch accessible, the orange pole standing proud of the snow surface. She made 6 trips down the hatch over those 3 days, retrieving firewood in backpack loads, keeping her stove running and her cabin warm. Each trip reinforced the value of what she'd built, not just a storage structure, but a system with redundancy, with backup plans, with engineering that anticipated failure modes and planned for them. The storm broke on March 9th. Clear skies, temperature rising to 28 degrees, the kind of false spring that comes to Wyoming sometimes before winter's final push. Sarah spent the next week digging out, working methodically to clear the main entrance ramp, exposing the door, confirming that the Quonset itself had handled the load without damage. The snow depth above the buried structure had peaked at 12 feet, 3 inches, roughly 13,000 pounds per square foot of static load, plus dynamic loading from wind and temperature cycling. The Quonset arch had flexed slightly. She measured 7/8 of an inch of deflection at the crown, but had returned to its original position once she'd cleared the snow. No buckling, no permanent deformation. The structure had done exactly what her calculations predicted. Miguel heard about the storm and drove up in late March after the roads cleared. He walked the site with Sarah, examined the Quonset, checked the emergency hatch system. "You planned for this," he said. "The backup access, that wasn't in your original drawings." "Added it after we talked about failure modes," Sarah said. "You and Carl got me thinking about what happens when the expected system fails. The emergency hatch was cheap insurance." "Most people don't think like that." "Most people don't have to." "No," Miguel agreed. "They just buy firewood from town and have it delivered." "Why didn't you?" It was a fair question. Sarah had spent 8 months building a structure to solve a problem that could have been solved by spending $800 on delivered firewood each winter. The rational economic choice was clear. Because delivered firewood doesn't teach you anything, Sarah said. It doesn't make you think about thermal mass, or snow loads, or moisture content, or soil mechanics. It doesn't force you to solve problems with your own labor and intelligence. And when the next problem comes, and there's always a next problem, you won't have developed the skills to solve it yourself. Miguel considered this. So this was never really about firewood. It was always about firewood. And it was never about firewood. Both things are true. April brought the melt. The snow didn't disappear all at once. It retreated slowly, exposing ground that hadn't seen sunlight in 5 months, revealing the damage and debris that winter had left behind. Sarah's property emerged like a battlefield, marked by broken branches, collapsed fencing, and the general chaos that comes from surviving something harsh. But the Quonset hut was intact. The cabin stood firm. And Sarah had 2 cords of firewood remaining when most of her neighbors were scraping by on fumes or burning green wood in desperation. She spent May and June on maintenance, replacing worn components, improving drainage around the entrance ramp, adding a small solar panel array to keep a dehumidifier running in the Quonset during summer months. The structure had proven itself, but proof wasn't the end. It was the beginning of optimization, of refinement, of learning from what worked and what could work better. Tom stopped by in early June, bringing Carol from the post office and Frank the propane delivery guy. They'd heard the story of Sarah's winter, the buried cabin, the emergency hatch, the firewood that stayed dry when everything else was frozen solid. "We wanted to see this thing," Carol said, standing at the entrance to the Quonset hut. "We heard about it all winter, but hearing and seeing are different animals." Sarah gave them the full tour, explaining the engineering, the backfilling process, the cross-bracing, the emergency access. They asked good questions, the kind that came from people who'd spent decades solving problems in difficult environments and recognized real solutions when they saw them. "You proved us wrong," Frank said. "All of us. We thought this was crazy." "It was a little crazy," Sarah admitted. "Crazy and calculated. Sometimes that's what it takes." "What are you building next?" Tom asked. "Nothing next, but there's always something." Sarah looked up at her cabin, at the hillside, at the landscape that had tried to kill her and failed. "That's the point of being out here. There's always something to solve, something to build, something to make work better. You stop solving problems, you might as well move back to town." They left as the sun was setting, 3 locals who'd become friends through the process of watching someone else succeed where they'd predicted failure. Sarah watched them drive away, then returned to her cabin and started a fire in the wood stove, using splits from the Quonset that were now bone dry, seasoned perfectly through a full year of controlled storage. The fire caught on the first match, always did now. She stood by the stove, feeling the heat radiating into the cabin, and thought about what she'd learned, not just about engineering or construction, but about the difference between theoretical knowledge and applied knowledge. About the value of proving things to yourself rather than accepting what others say is possible. About the satisfaction that comes from seeing a plan through from concept to reality, especially when that reality means surviving a winter that could have killed you. The Quonset hut buried beneath her cabin wasn't just a storage structure, it was evidence of something more fundamental. That problems have solutions, that solutions require work, and that work grounded in solid engineering and stubborn determination can overcome almost anything, even Wyoming winter, even 8 feet of drift snow, even the skepticism of people who'd seen too many newcomers fail to believe success was possible. But success didn't mean the work was done. It meant the foundation was laid for whatever came next, and in off-grid living, something always came next. Sarah added another split to the fire and settled into her chair, watching the flames dance against the stove's glass door. Outside, summer was coming to the Bighorn Mountains, bringing green grass and wildflowers, and the brief season when living at 7,200 feet was more pleasure than survival challenge. But winter would return. It always did. And when it came, Sarah would be ready, because ready wasn't something that happened by accident. Ready was something you built 6 months before you needed it, with your own hands and calculations and willingness to bet everything on your ability to plan correctly. She'd made that bet. And she'd won. If you're working on your own self-sufficiency projects, consider subscribing to this channel. We document real solutions to real problems, the kind of knowledge that matters when the power grid fails, or the supply chain breaks, or you just decide you're done depending on systems you don't control. These aren't hypothetical scenarios. They're the daily reality for people choosing to live beyond the reach of conventional infrastructure. And the lessons they learn, the mistakes and the successes, are worth preserving for anyone who might need them someday. The fire burned through the night, steady and clean, fed by wood that had stayed dry all winter beneath a cabin on a Wyoming mountainside. And that, more than any other measure, was proof that some problems really do have solutions. You just have to be willing to dig for them.